Hey everybody, welcome in. Mr. Lositis here. Let's get started with some review for multiplying fractions. This is for your upcoming quiz 4.4. All right, here we go. So first one here we're going to look at is a whole number times a fraction. We're going to try and look at that two different ways. And hopefully you had a chance to try this one on your own. We'll look at the correct answers here and then I'll give you another chance to try them. That's how we'll work this review. You'll see the problem, try it once, watch the video, and then get to try that problem again. If you got it wrong the first time. If you got it right the first time, you can skip that second time around and go to the next problem. Okay, so we're going to solve for the product of 2/3 times 5, first using repeated addition and then the associative property. So we can write this in two different ways, right? We can say 2/3 times 5. We could also say that equals 5 times 2/3. We're able to use that. I believe it's called the communicative property in multiplication, and this is going to get us the same answer. Let's look at this one first. We can kind of do these in two different ways. So this one lends itself to repeated addition because I have 2/3 and I need to do that 5 times. So I can just write it like that, 2/3 plus 2/3. I'll do it off camera here. Okay, so I got all my 2/3 lined up there. There's 5 of them because I need to do it 5 times. And then I just add the numerators. My denominator is already the same. That's 3. So 2 plus 2 plus 2 plus 2 plus 2. That's 5. Or it's 5. No, it's not. That's 10. My fault. It's 10. 10/3. Then I will have to simplify. So 3 can go into 10 3 whole times with 1 left over because 3 times 3 is 9. So I'll have 1 left over. I can convert that, simplify it into a mixed number of 3 and 1/3. So that's one way that I can do that. I can also show that as a model. Let me set up a model here. So I've got my model set up here. This is 2 out of 3 shaded in each one. So I have my 2/3 represented 5 different times. And then I could just count how many are shaded in. And it would be the same. It would be 10/3. And we could convert that into a mixed number of 3 and 1/3. Okay, let's clear the screen here and try it using the associative property. So this one will pretend that it says 5 times 2/3. Well, for me, this kind of doesn't lend itself to repeated addition quite as much because I don't want to add 5 2/3 of a time. So in my head, it just doesn't sound like a repeated addition question. I can still use it. I can still do 2/3 5 times. But instead, let's use an associative property. We know that 2/3 is equal to 2 times 1/3, right? It's 2 1/3. And I could show that in a model really quickly. So we could show it like that. So we can see in the model there, I've split 2/3, which looks like this, is 2 out of 3, into 2 times 1/3. And it's the same amount of things shaded in, right? There's 1/3 here, and there's 1/3 here. So if I add those together, I do get to 2/3. So that's just proving that this property does work. So that means I can rewrite this question as 5 times 2 times 1/3. And this might be easier for us to look at because we're working with a unit fraction here. A 1 over something is just easier to multiply by 1 whenever we can get there. So we can solve this by just doing 5 times 2, right? That's the first part. 5 times 2, that's 10. And then it looks like this, 10 times 1/3. Well, I know that 10 times 1 is just 10 because anything times 1 is the same number. And there's nothing to multiply on the bottom. So I have 10/3, which is the same as we had before, and we could again simplify that down to 3 and 1/3. So two different ways to look at that multiplication problem.